So, very good afternoon, all of you. Welcome back to electricity lesson of class 10 CBSE syllabus. This video we are sharing for education purposes only on behalf of Ambition Vedic classes. In previous class, we have studied about what is ammeter, what is voltmeter, and how it is used to find the current and potential difference in an electrical circuit. In addition to that, we have also seen the series arrangement of resistances, how the resistances can be connected in series, and connecting resistances in series means what. So if the left hand side and right hand side of the resistances are connected to other resistances, then we call them in series. Or if both the sides have a different point of connection, then we call them in series. So today we will revise again how the resistances are connected in series and the derivation that we have done, and then we will see what is resistances connected in parallel. Parallel means basically side by side. So how these resistances look like when they are connected in parallel, and again we will try to find out the expression for equivalent resistance that we have seen in series combination, and here we will see equivalent resistance for parallel combination. So before starting again, I would like to talk about what is equivalent resistance. I hope we have discussed in the previous class and everyone has understood. But again, what is an equivalent resistance? Equivalent means equal to, okay, which gives the same effect as of something else. So when there are many resistances connected in series, for example, we have taken 100, 200 resistances. So just imagine 100 and 200 bulbs connected together, and then if there is a fault in any one of the bulb, so then we have to find out what is happening to all these 100 bulbs actually. Apart from that, when we come back to resistances, so here equivalent resistance basically means when we are connecting 100 200 resistances together, and we want only one resistance in place of 100 resistances. If we want only one resistance, but that one resistance should give the same effect, okay, as that of 100 resistances, so such a resistance is known as equivalent resistance, which is producing the same effect as that of the 100 resistances. So 100 resistances we have to replace by only one resistance, okay. And here we are trying to find out some equation that will help us calculate the value of equivalent resistance. I hope everyone is clear. Any doubt, you can contact me anytime or put the message in the group. Fine. So let's start. In the previous class, we have seen how the resistances are connected in series. So as you can see, resistance R1, R2 and R3, these three resistances are connected in series. So just by looking at the diagram, how can we say that the three resistances are in series? So if we look at resistance R2, what we will find out is that right hand side of resistance R2 is connected to resistance R3, and left hand side of resistance R2 is connected to resistance R1. So both left hand side and right hand side are connected to different resistances, as we can see. So when this happens, when we see this kind of arrangement where left side is connected to someone else and right hand side is connected to something else, then we say that the resistances are connected in series. Series means in line, okay. No matter, even if we bend the combination and if they have the same connection, we call them to be in series, that we will see, okay. And also we have seen that these series resistances which are connected in straight line, we can think of it as a straight pipe, okay. So when we pour a water into the pipe, the water which is coming out of the pipe will be of the same amount that we have inserted or we have put it here at the entrance point. So here in this resistances, when the resistances are in series, same current basically flows through each one of the resistor. So current through the resistances is same when they are connected in series, right? But we have also discussed they can have a different potential difference. Okay, so all they have the same current, and they have different potential difference. So V1 across R1, potential V2 across R2, and potential V3 across R3. If we want to find out the total potential difference between this point and that point, it will be V1 plus V2 plus V3. That is what we have seen, exactly like this. So as you can see here, V1 is the potential difference between these 2 points. V2 is the potential difference between here and the second point, and V3 is the potential difference across resistance R3. Across means left and right, between left side and right side. Okay, then we have also seen the, because the current will remain same in the series combination. Okay, then we have seen that the total potential can be calculated as V1 plus V2 plus V3, and then from Ohm's law we already know V is equals to I into R. So for V1 it will become IR1, for V2 it will become IR2, because if you see what is V2, V2 is the potential difference across resistance R2. So this resistance R2 have current I passing through it. Okay, so I into R2 will be V2. Okay, and then substituting all the equations here in equation number 1, we obtained something like this: IR is equals to IR1 plus IR2 plus IR3, and then taking I common, because both of them they have the same resistance. Okay, and then I into R, I common, and if we cancel I, then equivalent resistance, the value for equivalent resistance will be equal to R1 plus R2 plus R3. So if there are many resistances connected in series, equivalent resistance can be quickly obtained by adding all the values. Okay, so if instead of 5 resistors are there in series, then we should add all the 5 values. Okay, also what we have seen is equivalent resistance for 3 resistances. All the 3 resistances, they have the same value. Here we have seen in previous case that resistances are written as R1, R2, R3. So this 1 2 3 indicates that all the 3 resistances, they have different values. This could be 5 ohm, this could be 2 ohms, this could be 1 ohm. Okay, but all of them are different, not equal at all. So here we can see all the 3 resistances that are connected in series, they have the same value, which is R. So it becomes somewhat like this: R plus R plus R, and total will become 3R. Similarly, if there are 100,000 or maybe 20,000 resistances which are connected in parallel, or n resistances connected in parallel, n could be 100,000, 20,000, 20, 100,000, it can be any value. So if there are so many resistances connected in value, and if every resistance has the same value, that means each resistance is of 2 ohms, or maybe each resistance is of 5 ohms, so then what we can do is we will add all the values. How many times? Here we have taken 3 times, so here it should be 100 times or 20,000 times, which is nothing but like this. So equivalent resistance for series combination, it is easy to calculate, which is nothing but n times the resistance of each resistor. Very important, how much each resistor value has. If all of them have the same value, we end up getting this. If all the resistors have different values, then we should add R1 plus R2 like 100 values. Fine. Then today we are going to see resistances connected in parallel. So what is resistances connected in parallel? For the sake of understanding, just have a look at this picture. Again, there are 3 resistances: resistance R1, resistance R2, and resistance R3. But if you check clearly here, I told you, we have discussed in series combination that if the left hand side is connected to some other point and right hand side is connected to some other point, then we call them to be in series. But here if you check, the left hand side of resistance R1 is connected at point A. The left hand side of resistance R2 is again connected at point A, and the left hand side of resistance R3 is also connected at point A. Again, right hand side of resistance R1 is connected at point B. Right hand side of resistance R2 is again connected at point B. And right hand side of resistance R3 is again connected at point B. So if we see here, what we find out that all the three resistances have their left hand side connected to the same point. Okay, and the right hand side of all three resistors are connected to the same point. Right, very important here again, because all the three resistances have their left hand side connected to one common point A, and right hand sides are connected to one common point B. Such an arrangement of resistors where one side of all the resistances are connected to one point and the other side of all the resistances are connected to another point, we call these resistance to be connected in parallel. Okay, parallel means side by side, like as you can see, side by side they are connected. So remember, all the sides if connected to one point, and all the other side of all the resistance are connected to another point, then we call them to be in parallel. Now what is so different in this parallel combination? If you see this circuit diagram, you can see that everything is connected to point A, and here everything is connected to point B. So there are two common points. Between these 2 points, all the resistors are connected, and we know what is potential difference. Potential difference is nothing but the concentration or difference of concentration of electrical charges between the 2 points. So that means if V is the potential difference between point A and B, so this V will be potential difference for R1 also, R2 also, R3 also, because all the three resistors are connected between the same point. So like we have seen in series resistance, the current is same. Here in parallel arrangement or parallel combination of resistances, potential difference is same. So like we know by Ohm's law, V is equals to I into R. There are three parameters. Okay, if one is constant, that means the other two values should change. If V is constant, then I and R should keep on changing in order to balance everything out. Left hand side should be equal to right hand side, LHS equal to RHS, to make it like that here. So as you can see, the potential difference across each resistor is same. Therefore we can say the potential difference across each resistor, that means every resistance have the same potential difference, because every resistance is connected between the same point. Even if you have 100 resistances in parallel, they will be connected between the same point, so they will have the same potential difference. But in case of a current, let's say when the current I is entering, as soon as it reaches the point A, it is broken down into three parts. Depending upon resistances, the current is broken into three parts: I1, I2 and I3.